Hi everyone, I'm Teacher Easy. Welcome back to our YouTube channel. Today, I'm going to talk about past year question from NMOS 2018, which is about the travel problem with ratio. Now, let's have a look. So we said that Peter and Queenie cycled toward each other from place A and B respectively at the same time. Peter was cycling faster than Queenie by 50%. After they met each other, Peter immediately increased his speed by 20%, and Queenie also accelerated by 1/3 of her original speed. It is known that when Peter reached place B, Queenie was 41 km away from place A. Find the total distance in km between place A and B. So everyone, how do we solve this question? So when you first read this question, you will see that, there is a lot of information that is given here. Now everyone, so every time when we are solving the travel problem, we can always try to draw the routing line so that we can understand the question better. So let's try to draw it together. So starting from, we know that there is two places, place A and place B. And in this case, we say that, Peter traveling from place A and Queenie traveling from place B. So both of them will travel and they will meet each other. In this case, because Peter was cycling faster than Queenie, you can see that, they will meet at a point that is slightly closer to Queenie. Now in this case, we say that after they meet each other, they increase their speed. So let's say this point, we call it the point C, when they meet each other. So now Peter will continue to move forward toward the place B, and for Queenie, it will also move toward the place A. So two of them will keep on continue in the same direction. But then when Peter reached the place B, we say that Queenie was still 41 km away from place A. So in this case, we know that this part is actually the 41 km. Alright, so these are all the information that we have from this question. Alright, but now, how do we want to solve it? So, any idea? You see, in this question, we need to find out the total distance. We might think that to find the distance, we need to know the time and we need to know the speed. But in this question, you see, we do not even know any of the time. And for the speed, we just know something about 20%, 1/3. We do not know the exact value. How do we want to find the distance? How do we solve this question? Alright everyone, let's look at one very simple example. Now, in this case, let's say, we have Tom and Jerry. We say that Tom and Jerry, the speed is 4 meters per second, Jerry 5 meters per second. In this case, we say that both of them travel for a total of 10 seconds. Everyone, what will be the distance for Tom and Jerry travel? So to get distance, we just use speed times time. So it will be 4 times 10, 5 times 10, you will get 40 meters and 50 meters. Now everyone, let's observe together. In this case, if I would like to know what will be the ratio of their speed, you see that 4 meters per second, 5 meters per second. Actually, the ratio of the speed is just 4 to 5. And we know that the time is being constant. And let's look at the distance. 40 meters and 50 meters. What will be the ratio? Again, after you simplify 40 to 50, you will still get 4 to 5. Now everyone, in this first example, you see that when the time is being constant, what will happen is that, we see that the distance ratio, it will be the same as our speed ratio. This is the first thing that we learn from here. Time is constant, distance ratio equal to the speed ratio. And we look at our second example. Again, we have our Tom and Jerry. This time, the speed will be 6 meters per second for both of them. And we say that, the traveling time is different here. One is 10 seconds, one is 20 seconds. Now everyone, again, how do we find the distance? We multiply it together, 6 times 10, 6 times 20, we will get a total of 60 meters and 120 meters. Again, let's try to look at the ratio. So you can see that speed is being constant in this example. And what will be the ratio of the time? 10 seconds to 20 seconds. Simplify, you will get 1 to 2. How about the distance ratio? 60 and 120. When you simplify it, also it will be 1 to 2. So in this second example, we can see that when the speed is being constant, distance ratio will be equal to the time ratio. So this is the second thing. Speed constant, distance ratio equal to the time ratio. Now, our third example, again, welcome our Tom and Jerry, and this time, we have the speed. Oh, Tom is 3 meters per second, Jerry is 5 meters per second. We said that in this case, both of them travel a total of 75 meters. We need to find out, what will be the time? So everyone, how do you find the time? So to find the time, we just have to use the distance divided by the speed. So in this case, we can see that, the time needed will be 25 seconds and 50 seconds. And again, we look at the ratio. So you can see that speed ratio, 3 meters per second, 5 meters per second, it will just be 3 to 5. And we say that time, 25 seconds, 15 seconds, what will be the ratio? 25 to 50, after we simplified it, you will get 5 to 3. Now everyone, in the third example, in this case, when the distance is being constant, we will realize that the time ratio over here, it is actually the inverse of our speed ratio. So the third example, distance being constant, time ratio is the inverse of the speed ratio. So this is the three things that we learned from our example, which is the relationship of the speed, distance, and times in terms of ratio. Now, when we know about this relation, we can now go back to our question. So everyone, in this case, do we able to get any ratio here? You see everyone, in this sentence right here, we say that Peter was cycling faster than Queenie by 50%. Now everyone, in this case, when you see the question saying, something faster than, slower than, we can actually know this is actually a ratio. In this case, we can know the speed ratio of Peter to Queenie because we said that it is 50% faster. We can first assume that, maybe Queenie, the ratio is just 1. So Peter will be 1.5. And after we simplified it, you will get 3 to 2. Now in this case, what will be the relationship in terms of the time? We say that both of them travel from place A and place B, and then they will meet at a point. The time for both of them travel is the same. We say that time is being constant. And last one, we need to know what will be the distance ratio. Based on what we have learned, when the time is constant, the distance ratio equal to the speed ratio, which means that in this case, it will just be 3 to 2. And now everyone, when we know the distance ratio is 3 to 2, we say that ratio can also be represented as a unit. In this case, we can say that Peter actually traveled for 3 units and Queenie traveled for 2 units. Now everyone, let's look at the next part after they meet each other. We say that Peter immediately increased speed by 20%, Queenie accelerated by 1/3. So we can also find the ratio of their speed. Now how do we want to calculate this? So everyone, when there is a 20%, percentage can also be represented as a fraction. So 20% will just be equal to 1/5. So to be able to know the new ratio, at first they are 3 to 2. So Peter, it will be 3 multiplied with 1 plus 1/5. So this is the original speed, the 1 is the original speed, and 1/5 is the increase. And then for Queenie, because increased by 1/3, so it will be 2 times 1 plus 1/3. So when you solve this calculation right here, everyone, you will get that the two fractions 18/5, 8/3, and we just have to remove out the denominator to simplify our ratio. So you just have to multiply the least common multiple, which is 15 on both sides. You will get 3 times 18, 54, and 5 times 8, 40. And then you just have to simplify again, you will get 27 to 20. Wow, everyone, which means that Peter will travel for a total of 27 units. Because again, when they meet each other and continue traveling, the time is still being constant. So distance ratio equal to the speed ratio. So we say that the solid line is where Peter traveled. This will be 27 units. This will be 20 units. Again, we're trying to label it on our figure. But now everyone, let's observe together. Now you can see that at this bar, we said that it is 2 units. this part, it is 27 units. Now, these two parts, actually, what is the relationship in terms of the distance? They are just the same distance, right? But in this case, one is 2 units, one is 27 units. Now, is the value of 1 unit the same? It's very clear that definitely they are not the same. So, to be able to compare it, we need to make sure that to unify our unit. Now, when we talk about unify the unit, you need to find something that is remain unchanged. Now, F1, which means that in this question right here, this part, the distance, they are just the same. So, we need to unify the unit based on here. One is 2 units, one is 27 units. You just first multiply the 2 unit on top with 27 and the 2 unit at the bottom with 2. And now, the unit will be unified. And now, you just have to find out what will be the value of 1 unit. You will be able to solve this question. Now, in this case, there is one value given here, which is a 41 km. Now, this 41 km, what is the unit that is corresponding here? You just compare our figure. You will see that this part is 3u times 27. This part is 20u times 2. So, when you compare it, we find the difference. You will know the unit for 41 km. So, we calculate it. 3u times 27 minus 20u times 2. It must be equal to the 41 km. When you solve this calculation, you will see that, 41 unit equal to 41 km. Which means that 1 unit is just equal to 1 km. And we need to find out what is the total distance from A to the B. So in this case, we can calculate from here. You can calculate from here. Doesn't matter. 2 ways is fine. Let's say we use this part to calculate. So the total distance, you need to sum out how many units is there. So F1, find out the total distance, 3u times 27 plus 2u times 27. There will be a total of 135. And we say that 1u equal to 1 km. So 135 times 1 will be 135 km. And this will be our final answer. Alright, so let's summarize what we learned from this question. First situation, first thing, we say that, when the time is being constant, what is something that we know? The distance ratio must be the same as the speed ratio. Second thing, when we say that the speed is being constant, okay, what do we learn from here? We say that the distance ratio is the same as the time ratio. The last one will be when the distance ratio is being constant. In this case, we say that the time ratio will be the inverse of our speed ratio. So these are all those things we learned from this travel problem. So now everyone, you can try to do this practice question and you can leave your answer at the comment section below. So you may join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.